Hello everyone. In this video, I will tell you about the third example in FCFS algorithm, right? So, in case of this algorithm, the number of processes which are given are process P1, P2, P3, P4 and P5. These are the five processes which are being executing in like operating system, right? So for that purpose, the arrival time is given over here. So for process P1, it is 3. For process P2, 5. Then 0, 5, 4 respectively, right? So just like that, like we are having the burst time, right? Burst time means the execution time, right? So that is also given for all the processes, okay? Now what you have to find out? So you have to find out the average, the average turnaround time, then the average waiting time, right? So, first of all, to find out the completion time, we must have to draw the Gantt chart, right? So, first of all, if the question arises that how to draw the Gantt chart, right? How to draw the Gantt chart, because here we are having the like different processes which are having the arrival time at like different like in the scattered form, right? As you could check that the process number P3 is arriving at the 0th quantum of time, right? But don't be confused within that, right? If the question arises like just like this, okay, then what you have to do, you have to check like which process is coming first, okay, which process is coming first, right? So that means like with the help of that you could check that the arrival time of all the processes, right? So which process is coming first? The process number the process number P3 is coming first into the memory, right? The process number P3 is coming first, right? As you could check the arrival time of that, right? So first of all, in case of Gantt chart, the process number P3 would be executed, right? So this would be the first execution, right? So process number P3 is coming, okay, at 0th quantum of time. And how much time it is taking for execution? That is 2. Okay, so it is taking 2 quantum of time. Now you just check like between the execution time till 2 how many processes are in the ready queue, right? So just check that how many processes are in the waiting queue. No process is there, right? There is no process which are waiting in a ready queue, right? Because we are right now at the at the 2th quantum of time, right? So the process number P1 is arriving at 3rd quantum of time, right? That means now the CPU has to wait, the CPU has to sit idly, right? The CPU has to sit idly till 3. Till 3, the CPU has to sit idly, right? Now, at 3rd quantum of time, the process number P1 has been arrived, right? The process number P1 has been arrived. And how much execution time it would take? As you could check the burst time of it, that is 4. So, it would be 3 plus 4, right? So, 3 plus 4, it would be 7, right? Now you just check like between like this 7th quantum of time, how many processes has been arrived, how many processes has been arrived, and like how many processes are waiting in a ready queue, right? So you just check if this process has been implemented at the 2nd point of time, right? Now the processes which are waiting is process number P5, process number P2 and process number P4, right? These 3 processes are waiting in a ready queue because the time is 7, right? That means between this 7 between the execution of this process P1, between the execution of this process P1, the process number P2, process number P5, process number P4 has been arrived, already arrived, right? Now we have to execute it one by one, right? So how we would execute it, right? How we would execute it. So FCFS algorithm says like the process which has been arrived first, that would be executed first, right? That would be executed first. Who is coming first, right? So that is why, like, you could check which is the smaller process, like which is arriving at the smaller quantum of time. So out of P2, P4 and P5, like P5 is arriving at fourth quantum of time, right? So that means the execution of P5 would be over here, and the total execution time is 3, so it would be 7 plus 3, that means 10. Then after that, process number P2 and process number P4 is in the ready queue. Now, so P2 would be executed, okay, and how much time P2 is taking? That is 3, so it would be 13. After that, like, we are having process number P4, right? So process number P4, it would be, right? Process number P4. After that, how much time it is just taking? 1. So it would be 14, right? So this is how we would draw the Gantt chart, right? And if you have drawn the Gantt chart for any of the algorithm, then obviously you could write the completion time, you could calculate the turnaround time as well as the waiting time, right? So with the help of this Gantt chart, you just write the completion time. So for process number P1, the completion time is 7. The completion time is 7. And the completion time for process number P2, the completion time for process number P2 is 13. It is 13. Now the completion time for process number P3 is 2. And the completion time for process number P4 is 14. And the completion time for process number P5 is 10. Is 10. Right? So this is how we are just writing the completion time. Now, you have to find out the turnaround time for different processes, right? So the formula for turnaround time is C minus A. That means C stands for the completion time and A stands for the arrival time, right? So the completion time, you just check 7. For process number P1, the completion time is 7 and the arrival time is 3. Okay, so it would be 7 minus 3, that means 4. Then the turnaround time for process number P2, it would be 13 minus 5, right? So it would be 8. Now the next one is 2 minus 0, so it would be 2. Then the next one is 14 minus 5, so it would be 9. Okay, then the next one is P5. So for that purpose, it would be like 10 minus 4. That means 6. Okay, so this is how we could find out the turnaround time for different processes, right? Now you just find out the waiting time, right? So the formula for waiting time is the turnaround time minus the burst time, right? The turnaround time minus burst time. So it would be 4 minus 4. 4 minus 4. So it would be 0. Then 8 minus 3. It would be 5. Then 2 minus 2. It would be 0. Then 9 and minus 1. It would be 8. And 6 minus 3. Right? It would be 3. Okay. But in question, you have to find out the average turnaround time. So, try to solve it. The average turnaround time is equals to 8 plus 4, 12, plus 2, 14, 14 plus 15. So, it would be 29 divided by 1, 2, 3, 4, 5 divided by 5. So, it would be 5.8 millisecond. Okay, so the average turnaround time would be 5.8 millisecond, and the average waiting time would be 0 plus 5, 5, 5 plus 0, 5 plus 8, 13, then 13 plus 3, 16, 16 divided by 5. So it would be 3.2 millisecond. Okay, so just like that, you could solve the different number of examples in case of FCFS algorithm under the unit that is process management, right? Hope you have understood all the videos related to the like FCFS algorithm, right? So if you have really liked the video, please do subscribe the channel, as well as like you just like the video, and do comment in the below comment box if there is any kind of problem. And if you really like the video, then obviously you could write in the comments in the below comment box, right? So till then, thank you so much, thanks a lot.